Here we have an equilateral triangle. So all angles are 60 degrees and all sides are equal in length. So let's do the following. On this right side, let's draw the midpoint of that side. And let's draw the segment that connects that midpoint to its opposite vertex. What we get is the following. That angle will be a right angle. Each of these angles will be 30 degrees. And if each side of the triangle, of the equilateral triangle, is x, then what we get is that each of these half segments will be half of x. Now let's pay attention to the top triangle where we have 30, 60 degrees. So that is a right triangle. I have the hypotenuse, I have one of the legs. If I want to find the other one, the other leg, I apply the Pythagorean theorem. So if that side is A, this side is B, and the hypotenuse is C, the Pythagorean theorem says that A squared plus B squared equals C squared. We can use this to find A. Let's plug in. So we get A squared plus. Now B is half of x. So when I square it, I get 1/4 x squared. That equals C squared, which in this case is x squared. Now, since I want to solve for A, I would like to get rid of all stuff around it. Now, I don't like working with fractions, so let me first get rid of this fraction by multiplying both sides of this equation by 4. So multiply both sides by 4. On the left side, I get 4a squared plus 4 times 1/4 cancel out, so that's x squared equals 4 times x squared. Now, I'm solving for a, so now let's get rid of x squared by subtracting x squared on both sides. Our result, 4a squared on the left. On the right, I have 4x squared minus x squared. That's 3x squared. Next, let's get rid of this 4. Divide both sides by 4. Now, on the left side, the 4's cancel, so we end up with a squared. Now, I am looking for a, so I would like to get rid of this square. So use the square root principle. A will be the square root of the right-hand side. Algebraically, it could be minus or plus, but since here we are representing the length of a segment, we dismiss the possibility of a negative. So we end up with a equals just the square root of 3/4 x squared. Now, simplifying that radical gives us the following. The square root of x squared becomes plain x. Now here we're going to get the square root of 3 over the square root of 4. But we know the square root of 4 is 2. So we end up with a equaling square root of 3 over 2x. Okay, now let's observe that with this triangle, we can now find the 6 trig ratios of the angle 30 degrees. So let's begin with sine of 30 degrees. What is sine of 30 degrees? We know that in a right triangle, the sine of an angle is the length of the opposite over the hypotenuse. In this case, the opposite to 30 degrees is a half of x, and the hypotenuse is x. Observe that the x's cancel, so we just obtain that the sine of 30 degrees is 1/2. Now, let's obtain the cosine of 30 degrees. Again, by definition, the cosine of an angle is the length of the adjacent side over the hypotenuse. In this case, the adjacent side is a root of 3 over 2x. So root of 3 over 2x over the hypotenuse, which is x. Observe that x's cancel, so we end up with square root of 3 over 2. So cosine of 30 degrees is square root of 3 over 2. Now, tangent of 30 degrees. The tangent of an angle is the length of the opposite side over the adjacent side. In this case, my opposite side is a half of x. My adjacent side is root of 3 over 2x. Now, the x's cancel, so I end up with 1/2 divided by the square root of 3 over 2. So 1/2 divided by the square root of 3 over 2. Divided because that is a division. Now, when we divide fractions, we keep the first fraction multiplied by the reciprocal of the second fraction. So I get 1/2 times 2 over the square root of 3. Observe the 2's cancel, so my tangent of 30 degrees is 1 over the square root of 3. Now, to obtain the remaining trig ratios, I will use the basic trig identities. Remember that the cosecant of 30 degrees is the same as the reciprocal of sine of 30 degrees. So we know the sine of 30 degrees is 1/2. The reciprocal will be 2 over 1. So that makes the cosecant of 30 degrees 2 over 1, which is the same as 2. Now, secant. What is secant of 30 degrees? Secant of 30 degrees is the reciprocal of cosine of 30 degrees. In this case, the cosine of 30 degrees is root of 3 over 2. So the secant of 30 degrees will be the reciprocal, which is going to be 2 over the square root of 3. And what about tangent of 30 degrees? Well, we know that tangent of an angle is the same as the reciprocal, I want cotangent of 30 degrees. Let me correct this. So what about the cotangent of 30 degrees? Well, we know that the cotangent of an angle is the reciprocal of the tangent of that angle. So in this case, the cotangent of 30 degrees is going to be the reciprocal of tangent of 30 degrees, which will be root of 3 over 1, or simply root of 3. Okay, so here we have all the 6 trig ratios of the angle 30 degrees. Now, we could also obtain all the 6 trig ratios of the angle 60 degrees because we have 60 degrees in that triangle as well. So let's take care of that. Let's take care of those right now. So I want the sine of 60 degrees. I want the cosine of 60 degrees. I want the tangent of 60 degrees. Now, sine of 60 degrees is what? Is the ratio of the opposite side to 60 degrees over the hypotenuse. In this case, the side opposite to 60 degrees happens to be length root of 3 over 2x. So it's root of 3 over 2x over the hypotenuse, which is x. The x's cancel, so we find that the sine of 60 degrees is simply square root of 3 over 2. Cosine of 60 degrees is adjacent over hypotenuse. What's adjacent to this 60 degrees here? Half of x. So I have half of x over the hypotenuse, which is x. The x's cancel, so we find that the cosine of 60 degrees is 1/2. And finally, the tangent of 60 degrees is the opposite over the adjacent to 60 degrees. In this case, the opposite is the square root of 3 over 2 times x over the adjacent, which is 1/2 times x. The x's cancel, so we end up with the square root of 3 over 2 divided by 1/2. Now observe that we can view this as 1/2 times the square root of 3. So I can actually cancel out the 1/2. The 1/2 cancels out with the 1/2, and I find that the tangent of 60 degrees is simply the square root of 3. Now I invite the audience to obtain the remaining Trig ratios for 60 degrees, which are a cosecant of 60 degrees, secant of 60 degrees, and cotangent of 60 degrees, by making the observation that the cosecant of 60 degrees is the reciprocal of sine of 60 degrees. In that case, it will be 2 over the square root of 3. Secant of 60 degrees is the reciprocal of cosine of 60 degrees, which will be 2 over 1. And finally, the cotangent of 60 degrees, which will be the reciprocal of tangent of 60 degrees, and the reciprocal of root of 3 will be 1 over the square root of 3.